Okay, let's do a little pre-cal here. And in part one of the video, I did not finish the lesson, so I'm going to go ahead and do that right now. Um, let's see here. Yeah, here we go. Let's change colors. First thing I'm going to tell you, a lot of people are going to jump right into here and just do their identities. You know, like there's some indifference identities for sign. Don't. You'll be very, very unhappy if you do that. The section that you should be more concerned with than anything else is that. Now you might say, well, I don't understand what that's asking. Well, that's where I step in here and hopefully I can help with that. So first thing I'm going to do is draw two triangles. I'm just going to make a little unit circle here. That's 0, pi halves, pi, 3 pi halves, and 2 pi. And it tells me that angle alpha is between pi halves and pi, which is just another way of saying that it's in quadrant 2. So this is going to be angle alpha. And it tells me that sine of alpha is 3/5. So sine is opposite over hypotenuse. So my opposite is 3, my hypotenuse is 5. Now to find my adjacent side, I can go 3 squared plus b squared equals 5 squared. Or maybe you guys know that something called a 3, 4, 5 rectangle. But if you did do Pythagorean theorem, you'd get that this side is 4. Here's the problem with that. The direction. You know, your geometry teacher probably taught you that you can't have a negative side in a triangle. Well, that's not necessarily true. This side is actually 4. It's not that the length or the magnitude is negative, it's the direction. You're heading to the left. You're left of the y-axis. That's what makes it negative. So the side length is 4, the magnitude is 4, the direction is negative. Let me erase a little here. I'm going to need a little more room. And yeah, that was what? 0 and 2 pi. I'm going to do the same thing here. I'll do it in a different color so you can tell them apart. I'm also going to draw a triangle beta here. So again, I got 0, 2 pi, pi halves, pi, 3 pi halves. So I'm given that it's between 3 pi halves and 2 pi. Tells me that triangle B or triangle beta is there in quadrant 4. Now it tells me that cosine is 12 over 13. That's adjacent over hypotenuse. So that's 12, that's 13. And I'll save you the trouble here, but if you went like a squared plus 12 squared equals 13 squared, you're going to get 5 for the length of that side. But again, we run into that same problem. The length of the side is 5, but its direction is going downward. So positive magnitude, negative direction. So that is where I recommend you start. Let's just get these two triangles constructed. And now the problem's really quite simple. Let me show you. So if I'm doing a question here, like part A, sine A minus B or alpha minus beta. To do it, I'm just going to use my identity, which is, again, I like singing songs here for this. Old Man Winter had a sine, cosine, cosine, sine, like that. And it goes angle alpha, angle beta, alpha, beta. I'm going to put those in parentheses because I know I'm going to multiply stuff. And then the sine will keep its sign. And from here, I'm just going to go sine of alpha. Well, here's triangle alpha. Sine is opposite over hypotenuse, 3/5. Cosine beta. Cosine is adjacent over hypotenuse. That's 12 over 13. Minus cosine A is adjacent over hypotenuse. So I get negative 4/5. And then sine of B, I get negative 5/13. So a little multiplication here. 3 times 12 is 36. 5 times 13. My handwriting is terrible. Hold that thought. Okay, let's try this again and see if I can do a little bit better with my penmanship. So 12 times 3 is 36. Over 65 is 5 times 13. This minus and this minus will turn to plus, but then this subtraction is going to keep it minus. And 4 times 5, or no, hold on, yeah, it was 5, is 20 over 65. So my answer is 16 over 65. That is the answer to part A. We're going to do the same thing here with the cosine. So let me change colors here. So part B, I'm doing cosine A minus B, alpha minus beta. Your identity, cosine, cosine, sine, sine. And unlike the sine, which keeps its sign, the cosine will change it. And then it's alpha, beta, alpha, beta. And then I'm going to go right back to the pictures. That's why I said this was so important. Cosine alpha, adjacent's negative 4 over 5. Cosine of beta, adjacent over hypotenuse, 12 over 13. Sine A, 3/5. Sine B, negative 5 over 13, which gives me negative 4 times 12 is negative 48 over 65, plus, what's that, negative 15? Oh, good heavens. Maybe if I wrote legibly, that wouldn't hurt. So negative 15 over 65. I believe that makes negative 63 over 65. Part C, I'm going to do two ways. I'm going to pause here for a minute so I can erase, and then I'll see you in just a sec. So, my identity for part C here, tan A minus B is tan A minus tan B, 1 plus tan A tan B, and back to the table. This is times right here. So tangent A, opposite's 3, adjacent's negative 4, so that's negative 3/4. Minus, not plus. Tangent of B, negative 5 over 12. Well, these two negatives are actually going to turn into a plus, but we'll deal with that later. And then on the bottom, I'm going to have 1 plus negative 3/4 times negative 5/12. Some of this can get a little gross here, so bear with me. So on top, I'm going to have negative 3/4 minus minus is plus 5/12. On the bottom, 1 negative times negative makes positive. 15 over 48. On top, I'm looking at my denominators here. This denominator is 4. This one is not 4. So I'm going to multiply this by a fancy 1, 3 over 3. So what does that do for me? Well, it's going to give me negative 9/12 plus 5/12. It's going to give me a common denominator, is what it's going to do. And this has a denominator of 48, so how can I write 1 so it has a denominator of 48? 48 over 48 plus 15 over 48. So let's see what that does for me. So I'm going to combine these. That's negative 4 over 12 divided by 63 over 48. Kind of awful, not gonna lie. And then dividing by fractions, same as multiplying by the reciprocal. Now, I don't know, I mean, you could do this on a calculator if you want. I like to be the calculator. I know that 12 reduces with 48, giving me the answer negative 16 over 63. Now, that being said, you can look at the work, you can kind of follow. There is no way on the planet I would do that. Not that it's wrong, it's just kind of time consuming. So you might say, is there a shorter method and would I be willing to share it with you? First off, yes, there is 100% a shorter method, and nothing would please me more than to share with you what that is. Just bear with me as I erase all that other work. And again, I did it that way first so you can kind of appreciate what it is that I'm about to show you. So, and like I said, there's certainly nothing wrong with the method I did. It's perfectly mathematically legit. I even don't believe I screwed up too bad, but here's the power of the trig identities. Maybe you remember that tangent is the same as sine over cosine. So tan A minus B is sine A minus B over cosine A minus B. You say, yeah, I get that. How does that help? I already know what those two things are. So that's 16 over 65 divided by negative 63 over 65. And then all I had to do is multiply by the reciprocal. 16 over 65 times 65 over negative 63. And I get that. So there you have it. That's how you can do these. Question I didn't ask, but I'm going to. Let me make a little like asterisk here. So what quadrant is A minus B in? You might say, well, how am I supposed to know that? I'm going to show you how you can know that. A little thing I teach my pre-cal is that in quadrant 1, all of the trig functions are positive. In quadrant 2, the sine is positive, cosine and tangent are not. Quadrant 3, the tangent's positive, and then here the cosine's positive. So if I look, in part 1, I have a positive value for sine. Well, sine's not positive there or there, so 3 and 4 are out. But my other functions are negative, which takes out 1 because everything's positive. So it would be in quadrant 2. I didn't ask it on the lesson, but certainly a cool thing to do. Just organizing where it's at based on the signs of sine, cosine, and tangent. One more just like it, and then I'll let you be here. So this is the important stuff right here. Again, I'm going to draw some pictures. I'm going to start with triangle alpha. It says alpha is between pi and 3 pi halves. Well, there's pi. There's 3 pi halves. So triangle alpha is in quadrant 3. It says tangent is 9 over 40. Tangent is opposite over adjacent. Now, if you look at the direction, they're both negative, left and down. And if you do Pythagorean theorem, this is going to be 41. And then, let me change colors here. We'll draw triangle B. B is between 0 and pi halves. Well, there's 0, there's pi halves. So there's triangle B. And it says sine of B is 7 over 25. So 7, 25. And again, I'll save you the a squared, b squared, c squared doing the Pythagorean theorem. This side would work out to 24. And it is positive because it's going to the right. So those are my two triangles. And then I'm going to do kind of like the same thing that I just got done doing. Sine A plus B So Old Man Winter had a sign. Cosine, cosine, sine. And the sign will keep its sign. So if it's plus here, it's plus there. And then I just look at the pages, or look at the pictures. Sine A, here's triangle A. Sine is negative 9 over 41. Cosine of B is 24 over 25. Plus cosine of A, negative 40 over 41. Sine of B is 7/25. And then we just do a little algebra. 9 times 24, if you don't know what that is, there is certainly nothing wrong with going old school. That's 216. So that's negative 216. Not sure why I know this, but 41 times 25, I believe, is 1,025. Negative 40 times 7 is negative 280 over 1025. So then if I subtract those, that makes negative 396 over 1025. Boom, that's your sine. Let's do cosine. Cosine A minus B is cosine, cosine, sine, sine. Alpha, beta, alpha, beta. And unlike the sine, which keeps its sign, this minus is going to be a plus. And then I'm just going to go up to my pictures here again, or actually, I already have the numbers right here. So for sine alpha, or was cosine alpha, we had, what was it, negative 40 over 41. Times cosine of B, which was 24 over 25. Plus sine A was negative 9 over 41. And sine B right here was 7 over 25. Negative 40 times 24 is negative 960 over 1025. Negative here, 9 times 7, 63 over 1025. Combined together, that's negative 1023 over 1025. And then lastly, to do the tangent, let me change colors one more time here. I'm doing tan A plus B. I can do the identity, tan A plus tan B over 1 minus tan A tan B. I'm not going to do that. I'm going to treat it as sine over cosine, because I've already found both of them. Sine of, yeah, let me make sure. Oh no, that is not going to work this time. The reason it's not going to work is because these two do not have the same angle. So I'm going to have to go old school on this one. So, oops. This one's probably going to leave a mark here. It may get a little gross and some of these numbers might be terrible. We'll deal with it. So then I'm going to have tan, this is part C here. I'm going to have tan A plus tan B over 1 minus tan A times tan B, or alpha and beta. So tan A, opposite over adjacent, negative negative is positive, 9 over 40. Let's check that just to be safe. Correct. Tan B, 7 over 24. And then on the bottom, 1 minus 9 over 40 times 7 over 24. Yeah. There's definitely going to be some bloodshed here. This is going to be some pretty awful numerical values. Let me erase a little. Yeah, we got some work to do. That's okay. We just roll up our sleeves, get a little dirty here, and come out on top. That'll work for me. Almost done erasing. I should have probably paused the video, but you could have fast forwarded through this too, so we'll make it work. All right. So on top, I got 9 over 40 plus 7 over 24. They do not have common denominators. I want them to. So I'm going to take this first one times 24 over 24. And the next, that 24 is really hideous. And this next one times 40 over 40. So when you add, I do need common denominators. On the bottom where I'm multiplying, I really don't care. So that's going to give me 1 minus 9 times 7 is 63. And we've already established that 40 times 24 is 960. So let's see what we're at right now. 24 times 9 is 216. And 24 times 40 is 960. Plus 280 over 960. So this has a 9060 on the bottom. I'm going to turn this 1 into 960 minus 960, or over 960. I'm just rewriting 1 so it has the same denominator as this. And let me see, that's 396 over 960 over, it's at negative 8. Let me see here, 960 minus 897, I think, over 960. And then change it to where we're multiplying by the reciprocal. So instead of dividing by this, I can multiply by the reciprocal. Maybe you heard something like keep it, flip it, change it, kind of like that, or copy, change, flip. I've heard it said a bunch of different ways. Those are toast. I get 396 over negative 897. That's terrible, but it's accurate. Hope that helps, and I'm going to close this out and hope this makes sense. Bye.